Good morning, students. It is, or good evening, whatever. Hello. It's Mrs. Cinti, and I'm here to talk to you about the set of real numbers, section 1.2. So what we're going to talk about is we're going to follow up on the idea of real numbers from section 1.1. This right here is called a Venn diagram. Venn diagrams are really, really useful. We use them in math or for logical sets of things, and we put things together that make, as you can see, all the natural numbers are here, but they are within this rational number idea. So this is what we were using to identify what type of numbers we were dealing with in the last section. And so it is again relevant in this section just to remind us what real numbers are, which is all of them, both the rational and irrational. And so just to remind you, the Venn diagram, it's just a cool new vocab thing. What are real numbers is kind of the next concept. Oops, let's go back. What are real numbers? Let's go ahead and put that definition in your notes here again, because it will be again relevant. So real numbers are both the rational and irrational numbers together. So all of them. Okay, so any type of number. So we're just dealing with all the numbers today, which kind of makes sense. So let's move on to, let's clean that up. What is a number line? Okay, number lines, as you see, there is an origin here. The origin is set at 0. And then what on the right of the number line are all the positive numbers, and on the left of the number line are all the negative numbers. And so it's important for you to see what a number line is, and then it will help us with all of these things. So you always want to think back to the number line and through the examples that we're going to do today. But it will help us with, and we'll go through each one of these one at a time. It'll help us with determining the magnitude of a number, so just how big is the number in comparison to other numbers, in looking at the absolute value, in looking at real number opposites using the additive inverse property, and then the closure property as well. Okay, so let's go through just a quick example of determining magnitude. So a question that you might see me ask you, or your textbook ask you, is something like, let's get out of black. Let's use green. Yuck. This green is a terrible color. But so an example is order from least to greatest, and these are the numbers that we're going to order. Negative 7/4. We're going to order negative the absolute value of 3. We are going to order negative 2. We're going to put in that order negative 1.9. We're going to put in that order negative the square root of 16 and negative 1.4. Boom. Okay, so all types of numbers is what we're seeing right here. So when we use a number line, it'll be helpful to know kind of where we're going. These are all negative numbers, or will turn out to be negative numbers. So we'll put the origin here, but we only really need this side of our number line to help us put these in order. I think this one and this one and this one are all very straightforward. They're all negative. The other ones require a little bit of work to be able to move into the answer. So let's put some energy into that. So 7/4 ends out to be, right, 4/4 is 1, so 7/4 is 1.75, and this value stays there, so negative 1.75. This one right here, absolute value means just what is the distance away from 0. So the absolute value of 3, so what you're doing is you look at 1, 2, 3. How many steps away is 3 from the origin? 1, 2, 3 steps away. So the answer, so the absolute value of 3 is 3. And then this negative sign is on the outside, so that means that it comes back on whatever that was. Okay, so those are the two numbers. -2 stays the same. I think my writing is improving here. -1.9 stays the same. Oopsies. Negative square root of 16, so we'll do the square root of 16, which you guys know is 4. And then this negative side is on the outside, saying that whatever comes out of that answer is going to stay negative. And then -1.4, repeating. So now we get to put them in order. So if this is -1, if this is -2, if this is -3, and this is -4, and of course you can do this, I'm sure, in your head, but it still is nice to see how the number line can help you if there are some things that are going to confuse you. So we have this -4, and so this is right there. Okay, so maybe we can get one more color here. And I don't know, what do you think? Blue? Blue's a good color. So we have the -4 here. We'll put it right here. Where's another number? We have a negative, so we've taken care of that one. What about -3? -3 is here. What about -2 is here? -1.9. So we're going to put that maybe right here. It's very close to this, but -1.9. We did that. -1.4, maybe here. And this is where the writing is deteriorating. And then we also have the -1.75. So maybe right here is the -1.75. So magnitude of least to greatest, we would just rewrite that. So -4 is the least. It's on the furthest side over here. So -4 will be the first one, then -3, then -2, then -1.9, then -1.75. Oopsies, 75. That is terrible. And then -1.4. And I think we're done. Okay, so this would be your answer, and I love it when you circle your answer. That's very clear. So just showed all of this work. I would like you to show your work as you're just practicing now, and then eventually maybe you can do this in your head, but I want to see where you're getting the numbers from. But that is determining the magnitude of a number by using the number line. And it's gone. Oops, now it's gone. Okay, now absolute value, and I guess I should have taught you this first, but absolute value is just looking for the distance. Okay, so, oops, so use back. I'm going to get so good at this, I know, eventually. But for right now, we're just going to focus on doing it right. Okay, absolute value, where am I in my notes, is how far from the origin which is known as 0 here, is the number, or is the value between the lines. Okay. And so, for example, if we look at 3, you can tell, here's your number line, here's 0, here's 1, 2, 3. How far away is it? We go 1, 2, 3. Okay, so it's 3, so the answer would be 3. Another example, what if we're talking about -2? Here we make our number line, 1, 2, -2, -1, and then our origin is here. How many steps is -2 away from 0? We go 1, 2, and so our answer is 2. And then what if we do something like this? I was trying to think of tricky ones for you. that may be weird just because of the negatives in there. So we've discovered that, well, I can do number line again, but we've discovered that if there's a negative in there, it's just looking for how far away from the origin it is. So here's 1, 2, -3. That is 1, 2, 3 steps away from 0. So this first part would be 3, but then there's a negative on the outside. And so it would again be -3 because this part is, here, let's do a color, because this part right here is the 3, okay, but then this has to be brought down as well, okay, that negative sign. So that's what absolute value is, and that's how it helps us. Let's look at number, at the third use of the absolute value. Sorry. I wonder, can I just click? Oops, no, I can't. Real number opposites is the next one. It uses the additive inverse property, and that property is represented by this. You need to get to 0. So if you have some number here, what do you add to it to get 0? Okay, so two real numbers are on opposite sides of the 0. So number line wise, when we look at a number line, oopsie, that is a terrible arrow. Okay, if we look at example number 4, if we are at, example letter B, if we are at -4 right here, okay, there are 4 steps to get to 0, our origin. How far on the other side of the number line do we have to go to cancel that out? So here's 4. I think the number line can be useful to visualize it, but potentially you guys can figure it out on your own. What do you add to -4 to get 0? So a little bit of algebra. Hey, that's the name of our course. So -4 plus a +4 equals 0. And I didn't need to put that positive in there because there is a positive there already. 0 plus what will equal 0? And hopefully in your minds you just said 0. So that's what real number opposites are. You'll just have to identify what is that number that you add to it to get 0 as your answer. And then our very last one is called the closure property. A number line can help us with closure, the closure property. So let's look at this. So what it is, you'll be asked to determine, okay, so you'll be asked to determine if each set of numbers is closed under the indicated operation. And what this basically means is, do all of these numbers, is the solution to any multiplication that occurs between the set of numbers, the set of numbers, is the answer also there? So, for example, let's go ahead and then it wants us to give a counterexample if it's not a closed. So just prove that the answer to all of these problems is not within the set. So for instance, okay, let me do an example to help explain this because I don't think I explained it very well. 0 times 1 is 0. So is 0 one of these numbers in the set? The answer is yes. 0 times 2 will also give us 0. So these are all supporting the fact that this is a closed statement, okay? 0 times 0, also 0. What about 1 times 2? 1 times 2 is 2. There we go. What about 1 times 0? We already did, is 0. What about 1 times 1? That will give us 1, which is also in our answer. What about 0 times 0? It will be 0. It'll be in there. What about 2 times 2? That is 4. Is 4 one of these answers? The answer is no. This would be the counter example to prove that this is not a closed operation. Okay, it's not a closed operation. Okay, here, okay, so you have to look at what it says. Is it, closed by addition, closed by subtraction, closed by multiplication, division, whatever it is. So here we have 10, 11, and 12. Can you show me that this is a closed operation, or is it not? And give me a counterexample. This one, by subtraction it says, so 10 minus 11 equals -1. is -1 an answer that's in here? The answer is no. And so that means that this is a perfect counter example for that. And so you would say that it is not closed. That would be your statement. Okay? And that's how you'd prove that. If you have further questions, as you know, we're going to go over this in class tomorrow. We'll go over all of your questions on this. I think just going through these examples is the best way to explain this to you, so we can do that some more in class. But basically, well, I said it. So do your homework. I'll say it right now. You're going to look at page 3 and 4 in your workbook and do numbers 2 through 32 even. You're going to have a couple of examples of each of these, but mostly a lot of closure property. And then we'll come to class practice and then move right along. Okay, have a good evening.